In section 8.5, we'll be solving system of equations with 2 variables, and then we'll work with 3 variables. In the first example, I have to decide if we're going to use elimination or substitution. Since these are already stacked up nice and neat, I want to use elimination. Notice how we have a 4y and a y here. I can easily eliminate the y variables by multiplying the first equation with a -4 to each of the terms. This will alter the first equation and change it into -8x minus 4y is equal to -28. For the second equation, I'm just going to bring it over, not do anything to it now, and that's going to give us 3x plus 4y equals 8. And that's the whole point of multiplying the first equation by -4, because if we were to add these two, notice how the -4y and the 4y cancels out, leaving us with -8x plus 3x, or -5x equals, and then -28 plus 8 is -20. I can divide both sides by -5, and so x is equal to +4. This is our first ordered pair, and then we're going to solve for y. I could choose to solve for y in any equation that I want. If I look carefully, I can use either the first equation or the second equation. I'm going to choose the first equation because that looks easier for me. So we have 2 times 4 plus y equals 7. 2 times 4 is 8. So we have 8 plus y equals 7. I could subtract 8 to both sides. This leaves us with y equals a -1. That means my ordered pair is the ordered pair 4, -1. So this is the solution to our first example. What this essentially means is our two lines intersect at a single point, and that point of intersection is 4, -1. If we were to graph these two equations, we would have a line that intersects at the point 4, -1. In example 2, notice that we have a variable solved for already. We have a variable of x. That means I can take this x and substitute it into the second equation. This is set up for substitution. 6 times 7 minus 4y. And again, I want to make sure I use parentheses every single time I do the substitution. And we're substituting it into the second equation for the x. Now I can distribute. 6 times 7 is 42. And 6 times -4y is -24y. Minus 5y is equal to -45. Let's collect like terms. We have -24y and -5y, which we can add together. 42 minus 29y is equal to -45. Let's subtract 42 to both sides to solve for y. And so -29y is equal to -87. Let's divide both sides by -29. This reduces to y equals 3, a +3. Now to solve for x, I can choose equation 1 or equation 2. It doesn't really matter, but it looks like equation 1 is the easiest one to use. So we'll write x equals 7 minus 4 times 3. And x simplifies to 7 minus 12, or x is equal to -5. And so my ordered pair solution is -5, 3 for our second example. For our third example, notice it's set up for elimination, and the easiest one to eliminate looks like the x to me. So let's multiply every single term for the first equation by 3. That gives me a 6x plus 9y equals 69. And so I can just write the second equation underneath here. I'm not going to do anything to it because we don't need to. If we were to add these two equations, notice the y's would not cancel out, only the x, and that gives us 11y equals 77. If I divide both sides by 11, y will be 7, and that's our y coordinate. I could use any equation I want. I'm just going to use the second equation. We'll plug in the 7 into the y. So this is negative 6x plus 2 times 7 equals 8. 2 times 7 is 14, so negative 6x plus 14 equals 8. I can subtract that 14 to both sides. And so negative 6x equals negative 6. We could divide both sides by negative 6. X equals positive 1. So my ordered pair is finally 1, 7. Since we have completed equations with 2 unknowns, let's try an equation with 3 unknowns. And notice they gave us a gift. They gave us y equals 4 down here in equation 3. If you look at equation 3, we are given a gift, y is equal to 4. And we can plug that into either the first equation or the second equation. And it clearly looks like equation 2 is the easiest one to plug that into because it only has 2 variables, so that's what I'm going to use. We can simplify this as 2x plus 12 equals 22. Let's subtract 12 to both sides. And so 2x is now equal to 10. I could divide both sides by 2, and that gives me x equals 5. This is our first coordinate, the x coordinate. We're given the y coordinate, and all we need to do is find z. Let's plug this x into the first equation, and we already know y is equal to 4, so I can also use that at the same time. Since this is set up for substitution, let's plug in the numbers. We have 5 minus 4 times 4 plus 2z equals negative 15. Again, we're replacing the x with a 5 and the y with a 4. This simplifies to 5 minus 16 plus 2z is equal to negative 15. Let's collect like terms. The 5 and the negative 6 becomes negative 11 plus 2z equals negative 15. I can add 11 to both sides to solve for z. This results in 2z being equal to negative 4. Let's divide each side by 2. And so z equals negative 2. And now we can write our answer. Our answer is going to be in the form x, comma, y, comma, z. And so our answer is 5, comma, 4, comma, negative 2. This is our solution for this problem. In this example, the tip that I have for you is to eliminate one variable first. If you can eliminate one variable, you will only have 2 variables, and we know how to solve system of equations with 2 variables. So let's look. What's easy to eliminate? For me, it looks like the z is going to be easy to eliminate. So I'll label the equations, equation 1, equation 2, and equation 3. I will look at equation 1 and equation 2, and we'll just stack these up and eliminate the z variable. So we have x plus y plus z equals 0 on top, and on the bottom it's 2x plus 3y minus z equals 24. I can add these up, and you can clearly see that we get 3x plus 4y is equal to 24. Notice there is only two variables, and that's great. We know how to solve equations with two variables. So using the first pair, equation 1 and equation 2, we have a two-variable equation now. Now you can use any of the other pairs, so let's use the second and the third pair. Let's stack 2x plus 3y minus z on top here. And on the bottom we have 3x minus 2y plus 4z equals negative 36. Again, this is equation 2 on top and equation 3 on the bottom. To get rid of the z, I would have to multiply the first. To get rid of the z, notice we have to multiply this equation by a positive 4. And we're going to do that to every single term. This gives me 8x plus 12y minus 4z equals 96. For the second equation, I don't need to do anything because the z's are going to cancel out when we add these up anyway. And so let's add them up. Notice what happens. The z's cancel out, and you get 11x plus 10y equals 60. And this is good. This is really good because now we have two equations in two variables. And I know how to solve these. We can stack them and use either substitution or elimination. I'm going to use elimination. Let's multiply the top row by negative 11. And we'll multiply the bottom row by a positive 3. The first equation simplifies to negative 33x minus 44y equals 24 times 11 is 264. So this is negative 264. For the bottom equation, we have 33x plus 30y equals 180. Let's add this up, and since we have negative 33 and positive 33x, they cancel out, leaving us with negative 14y equals, and we'll do the subtraction here. This should be a negative number. This is negative 84. Let's divide both sides by negative 14. And so y equals 6. This is our single ordered pair. Now we need to find the other two. I can plug this y equals to 6 into any equation I want, but it looks like I can use this equation. That's relatively easy. Or I could use this equation. That's also relatively easy. Let's use the one on top. Those look like they have smaller numbers. And so we'll do the substitution here. 3x plus 4 times 6 equals 24. So we have 3x plus 24 equals 24. Subtracting 24 to both sides. Notice this gives us 3x equals 0. And so x equals 0. That's our x coordinate. We have the y coordinate. And all we need is to solve for the z coordinate. And to do that, it looks like I'm going to use the first equation. That's the easiest one to do substitution with to solve for z. So let's plug it in. We have x is 0, y is 6, and this can solve for z. And this is relatively easy. We could subtract 6 to both sides. And so z equals -6 is our final coordinate. Let's write our answer in the correct form. My answer is 0, 6, -6. This is the coordinates that we need. X, Y, and Z. Let's try the problem again. And again, the tip is to eliminate one of the variables completely. So let's eliminate, in this case, I'm going to eliminate X because that looks like the easiest variable to eliminate. So let's give it a try. We'll start by labeling equation 1, equation 2, and equation 3. Let's stack equation 1 and equation 2 together and try to eliminate the X. And so we're just going to stack them up together and see what we can do to eliminate the X's. Notice the first equation can be multiplied with a +3. Let's multiply the first equation with a +3 to every single term. And so that's going to change my equation 1 into 3x plus 9y minus 12z equals -39. For the second equation, we're just going to leave that alone. We're just going to bring it underneath this equation. And so if we add them up, notice that they cancel out the x's. And so we have 18y minus 4z equals -44. And this is good. We only have two variables now. We use the first and second equations. Now we could use either the second and third or the first and third. It's up to us to decide. And for me, I'm going to use the first and the third. The numbers just seem a little bit smaller to use. So we'll use the first and the third equation as our pairs now. It doesn't matter which one you do as long as it's different from equation 1 and equation 2. You could use any other pair that you want. We're just going to copy equation 1 and equation 3 on top of one another here. Okay, so now we can eliminate the x because that's our goal. We wanted to eliminate just the x variables, so we have two variables left. Let's multiply the top equation here by 5. This gives us 5x plus 15y minus 20z equals -65. And on the bottom here, we're just going to copy it. We didn't do anything to the equation. If we add them up, see what happens. We get a 21y, because the x's cancel out, minus 14z equals 84. Double checking my work, I realize I made a mistake. This should be a -84 because we have a -65 plus a -19. So let's go back and fix that. Put that as a -84. Now we have two equations of two variables which we know how to solve. Let's stack 18y minus 4z equals -44 on the top, and on the bottom I have 21y minus 14z equals -84. This is a really ugly problem. It's difficult to eliminate the y or the z, so I'm going to be forced to use big numbers. Let's multiply the top equation by +14 to every single term. And for the bottom, we're going to use a -4 on the bottom. And I want to cancel out the z. Unfortunately, we were forced to use large numbers. So let's give it a try. 18 times 14 is 252 minus 14 times 4. 14 times 4, that's going to give us 56. So this is 252y minus 56z equals, and now we'll multiply 14 times 44, which is 616. This is negative 616. That's our first equation. Now for our second equation, we're going to multiply everything by -4. 21 times -4 is negative 84y. And 14 times 4 is 56. So this is negative 56z. Actually, this is a positive 56z because of these double negatives. So be careful. And this is equal to negative 84 times -4. 336. And this should also be positive. Let's add them up. And yes, we do cancel out the z's. That's the point. This simplifies to 168y is equal to, this is equal to negative 280. If I divide both sides by 168, this simplifies. We can reduce this fraction, and if you check with a calculator, it's actually divisible by 56. So this took me a while to find out that this does have a common factor of 56. And so we can reduce this fraction as 5/3. So this is negative 5/3 for our first solution. Now we can plug in that negative 5/3 into our equation here to solve for z. So which one is easiest to use? It looks like I'm going to use this equation here because 18 has a multiple of 3 in it, and so that's easy to use. So I'm going to use this equation. 18 times negative 5/3 minus 4z equals negative 44. The 3 reduces to a 1, and the 18 reduces to a 6. So this is negative 30 minus 4z equals negative 44. I can add 30 to both sides. And so we have negative 4z equals negative 14. If we divide both sides by -4, z equals 7/2. If I reduce this, we get 7/2. Another ugly answer. So we have 7/2 as z, negative 5/3 as y. Two really ugly answers. So let's summarize what we have found already. We know that z is equal to 7/2, and we know that y is equal to negative 5/3. Let's do the substitution now. We have x plus 3 times negative 5/3 minus 4 times 7/2 is equal to negative 13. Let's reduce, and you can see this simplifies to x minus 5 minus 14 equals negative 13. And so let's collect like terms. X minus 19 equals negative 13. We can add 19 to both sides. X equals 6. That's a good answer. So let's write our answer in the correct form. Let's write our answer in the correct form. Our answer is 6, negative 5/3, 7/2. It took us a while, but we did it. This is our solution.